everybody, this is dexxcore 2 string functions. Basically, a string is a struct that helps you manipulate C strings, which is tar data. C++ has its own string functions. I just created my own string functions so that I could control how it works. And how you create a string object is you call the string object's name and then you give it a name. For instance, now we've created a string object called string, and this creates a blank string. But you can also create a string and give it an initial value of a char, or a string or C string. Now, a C string is just an array of char data, and you would fill each element with a char, and then at the very last one you would set it to, which would indicate the end of the char. I'm pretty sure this is just the value 0, but basically at the end of every C string array there's a 0, and this is how when C out and other functions process strings, they're able to go through and figure out that it ends because it ends with a 0. But besides creating an empty string and a string with a C, with a char and a C strings, you can also create a string by using the constructors. Now, to understand how these work, you'll need to know a little more of how the string struct itself works. And how the string struct works internally is it has a int size that is defaultly set to 0, and then it has a char pointer mem that is defaultly set to null pointer. And when you create an empty string, technically it's not empty because it will set the size to 1 and then create a new memory block of size, and this will basically put a 0 in it. And then when you create a string with a single char, it'll create size 2. That way it can create a memory block with the char in it and a 0. And then arrays the same way. Since there's 5 chars, it'll create a size of 6 and then add a 0. But what these two functions do is this will create a string of size 5. So that means it'll put in 5 and the 5 memory, but it won't fill the array out with anything. So you've essentially actually created an empty string of size 5. What this function does is it doesn't do anything. It basically just leaves this data as is. So then technically you're truly creating an empty string of size 0 with mem null pointer. And the reason you want to do this is because maybe you want to set these values yourself, which is why in here it says don't do unless you know how a string struct works, because you would have to know about these variables and how to set them if you use this. But besides simply creating string objects, you can also get the size by calling the string dot size, and this will return the it would help if I spelled size right, but this would return the string size not including the 0. For instance, with string 2, which is array, it gives a size 5 because array has 5 chars in it. Or if you wanted to get the size with this 0 in it, you could either take this function and increment it by 1, or you can directly call size in the string object and read that variable. But this has basically been creating strings and getting the string size. But string objects also support different operators for manipulating the strings. For instance, the equal operator we've been using the whole time, because what these do is these basically create a string and then you set it to a specific value. For instance, here we have string 2, and if we were to take string 2 and set it equal to Zenity and run the program, we would see that the original string data has been completely removed and has been reset with Zenity. Now, if you wanted to keep your original string data and extend the given string data at the end of your string, you could use plus equal. And now when you run it, it says array Zenity because it's now plus equaled. It's added the string to it. But then there's also the equal equal, and this returns a boolean of if the strings are equal or not. And I can't really think of any particular reason one would use this, but I guess if you had a game that had user accounts and the user was creating a name, you might want to go through the list of your previous users to see if the name exists or not. So, like, basically you'd compare string 1 to string 2, and oh, I put them both as yes. I was like, why do they equal? Okay, anyways, you know, if you actually look what you're writing. But as you can see, string 1 does not equal string 2. So if this was a username and it doesn't equal the previous username, then you could create it. Now, if we were to make these strings equal, then they would be the same and the equal sign would return true. Now, this isn't going to work, and the reason why is because these single quotes are used with a char, and a char can only be one letter. And then when we use double quotes, that's saying that it's a C string, and a C string is an array of char data. So now that we've set it to C string, it's going to work. But as you can see, string 1 now does equal string 2 and it returns yes. There's also the plus operator, and what this plus operator does is string 1 plus string 2. Instead of working similar like the plus equal where it took the value and extended it on the previous string, it does work like that. It does take this string and extend this string to it, but instead of modifying this string, it actually creates a temporary string with both of these in it. For instance, now that we have this temporary string, we can output it. And that would display array Zenity, which is both strings extended onto each other. But this temporary string in memory, like when this function here finishes, string 1 plus string 2, you can use this temporary string to either display it or you can put it into a new string. So now that you've put this temporary string in a permanent string, you can use this string wherever you want. For instance, we can output it, and it shows that that string now equals arrays entity, which is string 1 and string 2 put together, and string 2 equals arrays entity because we added it here. But similarly too is you have the index box, which is what you use on arrays to get the individual indexes, and you can do the same thing with strings. For instance, if we were to take string 1 and access the first element, it would be a because that is the first element in the string, and if we were to choose a 1, it would be an R because that is the second letter in the string. But not only can you use this to display the index, but you can also use this to set a single char, and how you would do that is you would take this and equal it to Z, which it would have to be in quotes, and then we would output the string, oh yeah, so since this is accessing the individual element, it has to be a char because it is a char, and we can't set a char to a C string. But as you can see, arrays entity, you have successfully changed an individual element, and we can also display the element. But besides having the, so this has been like the string object and being able to set the strings and use the operations on the strings. But besides the basic string object, you also have string functions, which help you manipulate the string. And the first function is toString, and this is a very nice function because it will allow you to add many different types of variable types. For instance, if we had a int n equals 1, a float f equals 1.05, we would be able to just shove these in here, and we could shove in a C, we could shove in a char, a C string, and just numbers as well, and it would all work. So as you can see, the 11.05, the C from the chart, F1. Oh, okay, so we put the int first, so there's a 1 there, and then there's a 1.05 C, and then the string, and then the 2. But this works great for if you're, like, for instance, toString here takes given arguments and combines them into a string and returns it. So this creates a temporary string of all these values put together, and we take that temporary string and put it in our permanent string. And similar to here, you can display stats like HP and MP and put in values and be able to display your scores or whatever in games like that. But similar to toString, there is string set precision. And what this string does is it works with floats. For instance, if we were to put our float in here, and as you can see last time it showed 2 decimal places, we could use string set precision. And what this would do is you could set how many decimal places is going to be displayed on your float or decimal place. For instance, the range is only 1 through 6. For instance, if you were to put 0, it would be ignored, and if you were to put 7, it would be ignored. But if we were to put 1 and run it, it would only show the 0 in 1.05, and if we were to put 3, it would show a 0 in the third place because there's no number, and you can go all the way to 6. As you can see now, there's a lot of impending zeros. And then there's string start with. And what this function does is it returns a boolean if your string starts with a substring or not. And what this can be good for is, like, for instance, we have our each individual functions, like mem functions all start with mem, and string functions all start with string. So let's just say we're questioning this function, string with, and we wanted to know if this was a string function or not. We could check to see that if the string has the value string in it, and if it does, then it is a function, and if it doesn't, or it is a string function, and if it doesn't, then it's not a string function. So as you can see, string starts with is a string function, but if we were to check to see if mem new was, it would return no because it doesn't start with the string. And what that could be used for is, like, when I type in Visual Code, it gives me a list of functions, and you know, if you type in string dot, you could use this string starts with to look through a bunch of functions to pull out only the string functions that begin with string slash. The next function is string end with. String ends with. And this works exactly like string starts with, but it checks to see if the string ends with it. And what this could be used for is if you had a image.jpg and you were curious if it was a image.png, then you could check, and image.jpg is not a image.png, but the moment we change it to ping, it would say true. And also we have string count, which gives you the number of the substring that appears in your string. And basically you'll just give the function, you'll give a substring, and this doesn't return a boolean, it returns a number indicating the number of times it repeats. And so then we know that G appears in there 2 times, so it returns a 2. And if the string doesn't appear in there, it returns 0. And that's string count. It's pretty straightforward. Then there's string pose. So what this does is it'll search the entire string and find the substring, and when it finds the substring, it will return the index where it's at. For instance, John went to school and John went home. For instance, if we were to string pose check this string for John. So what this function does is it'll start at the beginning and search down until it finds John. And since John is at the first place, it'll return a 0. For instance, if we were to put a space and then try to search, it would give us a 2 because John is on the second index because the index starts at 0. 0, 1, 2. Now, some functions have an optional function, and what this means is you do not have to put it in to the function and it still works, and it has a default value. For instance, index defaults at 0, which means it defaultly searches at the beginning. But if we were to tell, because like we know John is located at 2, so if we were to put a 3 in here, it would start from this position and check for John. And because John is cut off, this doesn't count as a John, so it'll continue searching until it finds the second John, which would land us at 27. But basically, if you are looking at function definitions, pay attention to the optional because it's not required and it's also its default value. But similar to string pose, we have string pose last, and it works exactly like string pose but the opposite. For instance, instead of starting from the beginning and looking down, it will start from the end and look up. For instance, if we were to take away the 3, and which I realize I'm saying instant way too much, but if we search for John, since it started from the end and looked up, it would find the John at the location 27. And similarly, if we know John's at 27 and we start this at 28, it'll find the first John, which is landed at 2. We also have string replace, and this can be used to find a substring into the string and replace it. For instance, we're going to replace John with Tom, and then when we run it, it'll say error. Oh, I didn't even change the function name. Okay, so string replace. So now it says a Tom went to school and John went home. And there's also string replace all, and it's similar to string replace except it will replace all of the sub strings with Tom. For instance, if we run it now, it'll say Tom entirely instead of just John. As you can see, a Tom went to school and Tom went home. It's pretty straightforward. And then there's string copy. And string copy has the string, the index, and the count. And what this basically does is, this is your entire string. And what you're doing is you're selecting a index, for instance here, and then you're giving a count to how much you want to copy, and this will create a temporary string of this block. Yeah, so if we were to start at index 7 and we were to give it the string size dot size -7 because we went up 7, it would return that phrase, went to school and John went home. But another thing too is if you don't, like for instance, if you were to come in here and you were to put like a large number, the function is smart enough to know that the string ended, so it won't do anything crazy. And I don't know why you would, but for some reason if you just wanted to copy the entire string all over again, you could put 0 in at the starting location. But this is great if you have a string and you know a specific area that you would like to copy to a instant string and either output it or put it into a permanent string. And string remove is exactly like string copy, except it removes it. For instance, if I wanted to remove a space, I could start at the beginning and put 2 in there and then run it, and then it would be back to the original John went to school and John went home. Or I could choose an index and a size to specifically choose a region to completely remove. And it's the same thing. You can put a giant size in here and it will know it reached the end of the line. But also there is string insert, and none of these functions will change the original strings inside of the function. They all create temporary strings on the outside. And then you have string insert, and basically you could take the function, put a substring, and then the index you'd like to put it. For instance, if we were going to say this, and then we were to put it at the 15th place, and then make sure, yeah, I didn't even change the function, and then run the function, it would say, "A John went to dumb school and John went home," because in the 15th mark right here, we inserted the phrase space dumb, which completed the sentence. And then there's string upper, and you give it a string and you give it an starting index and a proportion, and what this does is it capitalizes all the letters within the string that are inside of the box you put. For instance, if we were to put let me change this function real quick. Upper function and index, so let's just say 2, and John is a 4-letter word. But as you can see, John is fully capitalized because we've selected this region of the string and we use the string upper function. You could also fully capitalize this string by calling func size, and it would do that as well. Or if you just don't feel like typing, you literally just, you know there's not going to be that many strings in it, so then you just run, and it's smart enough to know it reached the end of the string, so it's just going to capitalize it all. And we also have string upper all, and it basically just takes the string and then uppercases the whole thing. But as you can see, there's this yellow warning, and it's telling me to just make string upper where the index and the count are optional arguments. That way, if someone was to just put a string into the function, it would work as string upper all, and only if you were to specify a index and a count, which is specify a region, then it would uppercase that region. And that's just removing a whole nother function, because string upper all is a whole nother function that doesn't need to be, because string upper could be string function upper all. And then you have string lower, and it does the same thing. It just lowers uppercase values within a region. And similarly, you have string lower all, and it's the same concept. I really need to just make string lower index and count optional variables. That way, if you just type in the string with no other variables, it works as string low all. And then we have a few other functions here, and this is basically is upper. It returns true or false if the char you're looking at is a letter A through B. And then is lower, well, is upper returns true if the letter is capitalized. Is lower returns true if the letter is lowercase. And is alphabet returns if the letter is A through B. It doesn't matter if it's upper or lower. As long as it's an A or B, lower or higher, it'll return true. And digit will return true if it's a 0 through 9. And is special pretty much returns true if it's not a digit or an alphabet. For instance, an exclamation mark or a pound symbol. And then you have the string width and string height. These are going to be used for if you were drawing text to your screen. through OpenGL. For instance, if we were rendering text on the screen and we want it to be within a box, we would query the box's width and then the string width, and if the string width was bigger than the box width, we would go to the next line and we repeat this, maintaining the text in the box. And then you could also use the string height to where if the string is outside of the box height, you don't draw it, and then you could have like a scroll function that lets you scroll through the text. And then the final function is cstring function, which basically just lets you take an array of C strings and just get the size. But seeing how there's string functions, most people probably won't be messing with just pure C string functions. But this has been string functions, and they're very useful with manipulating text data or char data. And in the next video, I'll probably be covering the dexxcore functions and its functions that it includes. Thanks for watching and have a nice day.